Jai Hind, dear students, I am Supratim Saha representing Swami Vivekanand Subharti University, Meerut, and today I am going to discuss the topic quality of service. This topic involves introduction of QoS in IP networks, principles of QoS, divisions of QoS, and QoS routing, followed by the summary. If you look at QoS in IP networks, IETF groups are working on proposals to provide QoS control in IP networks, that is going beyond best effort to provide some assurance for QoS. Work in progress includes RSVP, differentiated services, and integrated services. It involves a simple model for sharing and congestion studies. Principles for QoS. Consider a phone application at 1 Mbps and an FTP application sharing a 1.5 Mbps links, that is megabits per second link. Bursts of FTP can congest the router and cause audio packets to be dropped. Want to give priority to audio over FTP is one of the primary reasons for that. Principle number 1 states that marking of packets is needed for router to distinguish between different classes, and new router policy to treat packets accordingly. Applications sometimes misbehave. For instance, audio sends packets at a rate higher than 1 Mbps assumed above. Principle 2. It provides protection, that is isolation, for one class from the other classes. It requires policing mechanisms to ensure sources adhere to bandwidth requirements. Marking and policing need to be done at all the edges. Alternative to marking and policing can be to allocate a set proportion of bandwidth to each application flow, which can lead to inefficient use of bandwidth if one of the flow does not use its allocation. The principle 3 states that while proving isolation, it is desirable to use resources as efficiently as possible. It cannot support traffic beyond link capacity, and 2 phone calls each requests 1 Mbps. Principle number 4 says that we need a call admission process where application flow declares its needs. Network may block all if it cannot satisfy the needs. If you look at the building blocks of QoS for network applications, we can clearly see it is having 4 different stages, that is packet classification, isolation, that is scheduling and policing, followed by high resource utilization, and finally call admission process. What are the building blocks? It involves scheduling, traffic shaping, modeling, and admission control with various algorithms mentioned within it. Now scheduling, that is choosing the next packet for transmission, involves first in first out, that is FIFO, priority queue, round robin, weighted fair queuing, and we had a lecture on that. That is packet dropping, not dropped tail, not only when buffer is full, active queue management, congestion signaling, explicit congestion notification, ECN. Buffer size. Why can't we use the infinite buffers? Because there cannot be no packet drops allowed, and therefore infinite buffers are supposedly not to be used. Small buffers, they often drop packets due to burst, but they have many small delays. Large buffers, that is, they reduce number of packet drops due to bursts but increase delays. Random early detection, that is also known as RED. So the basic premises involves the router should signal congestion when the queue first starts building up by dropping a packet. Router should give flows time to reduce their sending rates before dropping more packets. And we need to note that when red is coupled with ECN, the router can simply mark a packet instead of dropping it. Therefore, packet drops should be early, that is, don't wait for queue to overflow. Random, don't drop all packets in burst but space them. Followed by the red and TCP policy, that is, sequence of actions of early drop involves duplicating the acknowledgements, fast retransmit, that is, session recovers, lower source rate. Some other aspects are fairness in drops, that is, bursty versus non-bursty. Probability of drop depends on rate. Disadvantages include many additional parameters and increasing the loss. Now we come to the point of traffic shaping, which controls the rate at which packets are sent. That does not involve not just how many they send, but how the packets are sent and the rate of them. Used in ATM and integrated service networks. At connection setup time, the sender and carrier negotiate a traffic pattern that is shaped. Two traffic shaping algorithms are leaky bucket and token bucket. The leaky bucket algorithm involves the controlling of rate in a network, implemented as a single server queue with constant service time. If the bucket, that is buffer, overflows, then packets are discarded. Leaky bucket parameters R and B has to be calculated. Every time the R time units sends a packet, and then for an arriving packet, if Q is not full, that is it is not less than B, then NQ. We have to note that the output is a perfect constant rate. The token bucket algorithm has some of the highlights, that is the bucket holds tokens. To transmit a packet, we use one token. Allows the output rate to vary depending on the size of the burst. In contrast to the leaky bucket, granularity, that is packets or bits, the maximum tokens need to be considered. Generate a token every R time units. If number of tokens are more than maximum tokens, reset to maximum tokens. For an arriving packet, we need to NQ. While buffer not empty and there are tokens, we need to send a packet to discard a token. Some of the approaches to quality of services are divided into two parts, that is depending on integrated services and depending on differentiated services. The integrated services approaches include network-wide control, admission control, absolute guarantees, traffic shaping, reservations, and RSVP, which also means resource reservation policy. The differentiated services, on the other hand, involve router-based control, per hop behavior, resolves contentions, hotspots, relative guarantees, traffic policing at entry to network. The IETF integrated services have the architecture for providing QoS, which guarantees in IP networks for individual application sessions. Resource reservation, routers maintain state info of allocated resources, that is QoS requests. They admit or deny new call setup requests. Now if you look at the QoS guarantee scenario, we can see the resource reservation, that is call setup and signaling through RSVP, the traffic, that is QoS declaration, the per element admission control. Now RSVP requests involve a token bucket specification, bucket size, say take it as B, token rate, say take it as R. The packet is transmitted onward only if the number of tokens in the bucket is at least as large as the packet. So peak rate can be given by P, which is always greater than R, which is nothing but the token rate. The maximum packet size is M and minimum polished unit is small m. All packets less than small m bytes are considered to be m bytes. It reduces the overhead to process each packet. Bound the bandwidth overhead of link level headers. Continuing, the RSVP requests, it involves an indication of the QoS control service requested, controlled load service and guaranteed service. For controlled load service, simply a T specification. For guaranteed services, a rate, that is R term, the bandwidth is required, capital R greater than or equal to small r, where extra bandwidth will reduce queuing delays. A slack, also known as capital S term, and the difference between the desired delay and the delay that would be achieved if rate capital R were used. With a zero slack term, each router along the path must reserve capital R bandwidth. A non-zero slack term offers the individual routers greater flexibility in making their local reservation. Number decreased by routers on the path. There are multiple constraints as well. That is, a request specific process can involve the desired QoS requirements. For an example, BW, delay, jitter, packet loss, path reliability, etc. Three main types of constraints are additive, that is delay, multiplicative, that is loss rate, and maximum or minimum, that is bandwidth. If we look at the task, we need to find a minimum cost path which satisfies the constraints. If not feasible and if no feasible path is found, we reject the connection. Generally, multiple constraints is hard computationally, that is for computation purpose, and simple case bandwidth and delay. IETF differentiated services, scalability, signaling, maintaining per flow router state, difficult with large number of flows for obvious reasons. Flexible service models. Intserv has only two classes. Also, they want qualitative service classes. They behave like a wire. Relative service distinction, platinum, gold and silver are some of the different classes. The approach can involve simple functions in network core, relatively complex functions at edge routers or hosts. Don't define service classes, provides functional components to build service classes. Edge router packet marking. The profile involves pre-negotiated rate A and token bucket size B. Packet marking at edge based on per flow profile. User packets. Possible usage of marking. Class-based marking, packets of different classes marked differently. Intra-class marking, confirming portion of flow marked differently than non-confirming one. Classification and conditioning. The packet is marked in the type of service TOS in IPv4 and traffic class in IPv6, which are network parameters. 6 bits are used for differentiated service code point, which is also known as DSCP, and determine PHB that the packet will receive. 2 bits are currently unused. The classification and conditioning. It may be desirable to limit traffic injection rate of some class. User declares traffic profile, for an example rate and burst size, etc. and traffic is metered and shaped if non-conforming. The forwarding process involves per hop behavior result in a different observable, that is measurable forwarding performance behavior. PHB does not specify what mechanisms to use to ensure required PHB performance behavior. Some examples include, say class A gets X% of outgoing link bandwidth over time intervals of a specified length, and class A packets leave first before packets from class B. Now we are into the final stages of forwarding, that PHB is being developed, that is expedited forwarding. Packet departure rate of class equals or exceeds the specified rate. The logical link with the minimum guaranteed rate, that is premium services. Assured forwarding, that is 4 classes of traffic, each guaranteed minimum amount of bandwidth, each with 3 drop preference partitions, namely gold, silver and bronze. I hope this was informative for you and thank you for watching. Jai Hind.